Today I'm going to be taking apart the lower unit for a Suzuki DT150S from 1993. The stopper nut here is corroded, so what I'm going to go and try and do is use the drill to cut the nut into sections to remove. I started with a small drill bit to create a pilot hole, and later followed with a larger drill bit that would cut through the stopper nut but not mess up the threads on the inside. After cutting the stopper nut into sections, put the stopper or retaining wrench onto the nut and try to break it free. If it does not come off with the wrench, use a hammer and a chisel to break each chunk free from the corroded threads. Use a Dremel or a similar tool with a wire brush attachment to clean out the corroded threads. So this whole setup actually works. I saw it on a YouTube video and the guy was running it on a freshwater motor, and he said he didn't know if it would work for a saltwater motor, and he saw how corroded the ring was. So I was skeptical, but it's out and it works pretty well, so thanks to that dude. After using the puller, remove the bearing carrier and then the prop shaft. Next, remove the bolts holding the bearing housing for the drive shaft. Once the bolts are out, use pry bars or flatheads to work at the housing, being careful not to scratch anything. Make sure to keep track of all needle bearings and shims. Clamp a portion of the drive shaft that does not interact with bearings or other components. Avoid clamping the splines, smooth and shiny surfaces where bearings ride, or where the water impeller sits. Oh, the shaft is turning. If your drive shaft nut is being stubborn and won't come off, you may have to weld an extension nut to be able to apply more torque and get a better grip. The heat will also break any corrosion or Loctite that is on the drive shaft. Once the drive shaft nut is off, place a pair of vise grips in an unimportant area of the drive shaft and give it a few taps to remove the shaft. Here we can clearly see the areas to avoid on the drive shaft, which I mentioned earlier. So I got everything out, and now I just got to pull out all those needle bearings and count them and make sure I haven't lost any. Remove the forward gear assembly and inspect the gear for any chips or wear. Also inspect the roller bearings for any uneven wear or scratch marks. Remove the bolts holding the shift rod assembly, and then use a chisel or a flathead to pry out the whole assembly. So I need to replace these two oil seals, so my plan is to have this go in there like that, and then this large socket just go here so that the oil seal can fall into the larger socket. So there's one of them, and let's see if I can get the other one out. So now I have the problem where this fits into the oil seal, so it's not going to push it out. I'm going to try to use screws and put them into the metal part of the oil seal, and then use a crowbar or something to pry up on them. I'm gonna put this flathead here just so if I pop through I don't damage the bearing. Now that I have my hole, I can put my screw in and then repeat on the other side. Now we're gonna try to pry up on the seal. And the reason I'm not using the flathead right now is because Suzuki uses double seals, so it's 2 seals, so I'm just hitting the one on the bottom when I do the top. When I do remove the bottom seal though, I will use a flathead again to stop the drill bit from hitting anything important. This screw right here just went into the bottom oil seal, so you just gotta pull it out. And then there's the outer bearing carrier seal, which is, it's okay, but I'd rather just replace it all right now. Which is also probably okay, but I already bought all the seals needed. The real reason for taking everything apart was because I tried to shift gears and it wasn't happening. And so I noticed when I flipped the lower unit on either side, it would shift in between forward or reverse, respectively on which side it was leaning on. And so I took it apart to get at this horizontal slider that actually interacts with the clutch dog. And this is the part that was broken, obviously. So that's exactly what I bought. Sadly, it's the last part. You know, you have to take everything out to access it. Especially this broken piece. This broken piece was the hardest to get out. Actually, that's false. This whole thing was a bitch. So we started with the corroded stopper nut, we'll call it, that had to be drilled in several places to take off. And then we went to a sort of homemade bearing carrier puller, which again is just a normal puller extended with chains. And then we used hardware to attach it to one of the 4 extrusions in the bearing carrier to pull it out. I ordered a drive shaft socket, which was the wrong number, even though it was the one that was called out in the book. So what I had to end up doing was cut it so that when you compress it, this radius changes a little bit. It's super sketchy. I would not recommend it. And then I welded this bead so that it would hold better in the vise and wouldn't spin. I also, as you guys saw, welded an extension nut on the bottom of the drive shaft nut just because it was hidden in there, and that worked really well. And we'll take a look on the inside and see how much cleaner it is. I used a wire brush to clean out the inside of here where all the corrosion was. So let's put in the new oil seals. I also cleaned out the inside of the bearing carrier. So let's replace these oil seals as well. When finding a socket, I would heavily advise finding a socket that fits inside of here, because if you put something inside and then you bang it, you can actually mess up this spring which keeps tension on the seal. So I would just try to find something that's about the same diameter as the whole seal so that you don't mess up the spring. I think this is going to be the most challenging part, but it's getting these needle bearings back into their race. So what I'm doing is I have some grease on my finger. I'm going to put it inside the race and it's going to be sticky enough to keep those needle bearings in, hopefully. Okay, perfect. I apologize for the camera moving so much. The camera is just resting on top right there, and the whole thing's on strings so I don't scratch it. So I don't want to mess up the new paint job. I'm gonna put the forward gear in now. I know it's kind of hard to see. To install the pinion gear, pull up on the drive shaft and then push down and rotate until the splines align. Still need to push down the drive shaft so that it pops out. So the next step would be to put the washer and then drive shaft nut. I'll put a little bit of grease on there. And hopefully it'll stay stuck. Before I secure the pinion nut, I want to put this bearing back on, as well as another bearing with the housing. So there's that hole. Hopefully just be able to shove this in there. Take some waterproof grease and put it on the bolts to make the maintenance next time be easier. Put some Loctite or thread locker onto the drive shaft nut. Make sure you have everything ready, as you only have about 15 minutes before it dries. It says 101.5 to 108.5 foot-pounds. So there's 105. So now that I got the drive shaft nut torqued, I'm gonna put the prop shaft in. So first you just need to put this little stopper back. And then this has to face upwards. It doesn't want to go all the way, so I'm gonna put some oil on it real quick. There we go. Let's get a little better view. Next thing comes the reverse gear. So there's this little lip, and there's actually a spacer that goes there. So hopefully I can drop this spacer in. It went in actually perfectly. And then we'll put in the shaft housing with the key and hope that the key doesn't come out. The key doesn't want to go in because I got a little bit of paint. Super hard to see actually. Okay, perfect. The bearing housing that we just put in is that darker metal, and it's lining up perfectly with the cast housing for the lower unit. So these tabs get bent once the stopper gets put on, and many people put thread locker onto the stopper. I'm using marine grease just because it was such a pain to get it off. And also because these tabs should keep it in sort of like a cotter pin. So I'm not really worried about this coming off. So the book says I need 130 foot-pounds to torque this, so let's see if I can do it. Now I just bend up these little tabs where I can. There's one of them that I can bend, and there's the other one. And these obviously I can't. So the last step is to install the shifter. And this is a new rod because the old rod was super bent. I'll show a picture, but it basically happened because the piece was broken and I applied too much force. So let's put this in. So since it's all done now, I'm testing the seals. And so the first test would be a vacuum test. So I went ahead and pumped this up to 15, and then we're gonna wait 5 minutes and see if it holds. So after 5 minutes, the vacuum pump still read 15 PSI. So it should hold true that the pressure test would work as well, or would give us the same result. But just to test it, I've loaded this thing to about 15 PSI, and then I connected it to a nozzle, and then to that same clear line I was using, I put O-ring. So we're going to connect it again and test. Some soap and water, and spray it on the seals. There's nothing leaking there. So the next step will be the water pump. So what I found out from research is that all Suzukis, starting with the 150s up to the, I don't know what it goes up to, but they have this option for another water intake, and it's a high water intake. So mine doesn't need it because it's the 150, so it's the smallest model of those that it's applicable. So then you have these little seals to put in place so that it doesn't pull in air or anything. So now let's get started with the water pump. So first goes the gasket, and then the plate. Next, we'll put in that new key. And then the impeller has a groove for the key. Then I like to take some of the waterproof grease and put it around the fins. As well as the track that the fins will travel. The housing goes on last. The best way to get this on is to push down and turn clockwise the way that the shaft will be rotating. And that should just help it fall into place. Like I said, I like to put some of the grease on the bolts as well because I don't want to struggle taking them out again when it's time to service. So now that's all complete, let's see it work. It's in neutral right now. And then we'll put it into forward. And then back into neutral. And then reverse. Back to neutral.